In this video, we're going to deal with equation manipulation, okay, which is basically rearranging an equation to make it look the way we want it to look. This is a valuable skill in algebra and in science, all right? And being able to move things in an equation around correctly is going to allow us to solve a lot of problems, okay? So I'm going to go through several different things we can do with an equation. We can add and subtract things. Okay, we can multiply and divide. We can deal with exponents. And then eventually we're going to solve things. Okay? So those are the things we're going to deal with. Okay? And in algebra and an equation, anything that you can do to an equation, okay, can be undone as well. So if I can add something to one side, I can subtract it back over. Or if I square something on one side, I can square root it and make it go away. So everything is reversible. That's important to know. So the first thing I'm going to do is I'm going to show you how to add and subtract things in equations. Okay, so for instance, let's say I want to get my x's here together. I want them to be on the same side of the equation. Well, if you're going to change an equation like this, you have to do everything to both sides. And let me show you what that means. So if I want to move, let's say, this x over here to be with its 5x friends, its like terms, all right, I have to add the x to both sides. What I'm doing is I'm getting rid of the x on this side, but I'm kind of keeping an accounting book and saying, hey, it's going to come back up over here. So now I have 6x plus 6x squared plus 6 equals y squared plus 7. As you can see, right, everything we have here is all still accounted for. Nothing has really changed. We've just moved something to the other side of the equation. Okay? The same thing can be done, okay, with subtracting. So, for instance, let's say I want to move my 6 over here to be with the 7. I could subtract it, and I would do the same thing. I would subtract the 6 over here and subtract it over here. You have to do the same thing on both sides of the equation. So if I subtract the 6's go away, and I have my new equation now, 6x plus 6x squared equals y squared plus 1. Okay? This is called simplifying. As you can see, my equation is getting smaller as I continue to simplify. I'm condensing everything into a simpler format. Okay? The next thing I'm going to do, okay, is deal with exponents and solving. Okay? So at this point, I've determined I want to solve for y. Okay? That's something that you're going to have to do in algebra. Okay? You want to be able to solve for y. It's going to come in handy with graphing. So if I solve for y, I'm going to move everything away from y, and I can do that just like I've been doing. I'm going to move my 1 over here, and I'm going to rearrange this into descending order. So I'll get 6x squared plus 6x minus 1 equals y squared. Okay? Notice that you can move things over even if there's not another version of it on the other side, even if there's not a like term to combine it with. So right here I moved my plus 1 over, and now it's a negative 1 on this side of the equation. That's okay too. Next, to solve for y, I want to get just y by itself. Not y squared, just y. So what I will do to eliminate the square, the exponent here, is square root it. And if I do it to this side, I have to do it to this side as well. So I'll end up getting y equals the square root of 6x squared plus 6 minus 1. Okay, and that means I've solved for y. I have y on one side of the equation by itself, and I have something that's equal to it. That's what solving for a variable is. Okay? If I wanted to undo this square root, I could simply reverse it. I could square both sides, and I would move back up to where we were before. 6x squared plus 6x minus 1 is equal to y squared. So everything that we do in an equation is reversible. There's a way to undo what we've done. Okay? That's what's cool about equations. You can rearrange them and manipulate them to the point where you want them to be. Okay? That leads me to my second example here. This is the ideal gas law. Okay? It's a chemistry and physics concept. And it deals with how gases interact with each other based on their pressure, volume, temperature, okay, and how much of it there is. Okay? And it's written as this. It's called the ideal gas law. It's got pressure, volume. This is the number of moles, or the amount of something you have in your solution. This is a constant called R. It's a really small number. And then temperature, which is measured in Kelvin. Okay? And we can manipulate this equation in many different ways to get certain information from it. So for instance, let me solve it for T. Okay, and I can see how temperature is based off of other things. So to do that, I'm going to divide N and R on both sides because they're being multiplied together. That cancels these out on this side, and it leaves me with T equals PV over NR. So now I know that temperature of a gas, an ideal gas, is its pressure and volume divided by the amount of gas times this constant. And I can use that information. So if I don't have a thermometer and I can't figure out the temperature of my gas, I can measure its pressure and volume, and I can figure out its temperature, as long as I know how much of it I have. Okay? I can do the same thing for the pressure and the volume. So if I rewrite my ideal gas law here, okay, if I want to define the pressure or the volume, I could divide the other variable away, right? And get a new equation that either looks like this or this. Okay? All of these equations are useful in an actual scientific setting. You can use them to find out different things based on what you can actually measure. Right? Science is about making observations and measurements and collecting data. And if you can't get the data of something, maybe because you don't have the instruments or you don't have the facilities to do so, you can find the other things, and because they're related in this equation, you can solve for what you're looking for based on the other data you've collected. So equation manipulation is extremely helpful. One last example we can do, for those of us who are in my science class, okay, we can do the same thing with any equation we do in science. So for instance, right, let's just say we've got the speed equation here. Speed equals distance over time. Okay. Based on what you want to solve for, you can change this equation around and do all sorts of things with it. So let's say you know that a race car is traveling at a certain speed, and you know how long it took for them to get to where they need to go. You can calculate the distance simply by changing the equation, by manipulating it. So for instance, if I multiply this side by time and this side by time, I'll know that the distance that the car travels is going to be equal to the speed it was traveling times the time it took for it to get there. So, being able to manipulate an equation in science as well as other things like economics, government, stuff like that, accounting, okay? All those things are super useful so that you can determine things if you don't have all the information you think you need.